big providers of this service, and then there was also dialpad.com. And you could get this working. You could connect over the internet to this company and then make a phone call. And in the domestic United States, it was even free at one point for making phone calls doing this. But where the money is, of course, is not places where it hardly costs anything to make a phone call anyway, like the domestic United States. It was for making international phone calls to places that cost a lot of money. And Net2Phone used to run the scoreboard on page 2 of USA Today, where they would list the daytime operator-assisted rates from AT&T to phone various countries, and then they would have their rates beside it. And usually Kenya topped out the list at $3.68 a minute, and then there'd be places like Myanmar and Afghanistan and India and Pakistan and Korea, and they would say, well, did they say $3.68 a minute? We'll do the communications for 69 cents a minute. And this is a niche market. But the bottom line here is that you have to go over the internet to get to their gateway. This is different than the cable TV story, because with the cable TV long distance story, it's the cable TV company is taking care of providing the access and then the long distance. In this story, it's your internet service providers providing access, and they're not worried at all really about quality of service to the level we need to do voice communications. So it's kind of hit or miss for the first part of the story, going from the hobbyist's computer across the internet to a gateway to turn it into a regular phone call. And that ends up being the weak link in the chain. With cable TV or DSL-based telephone service that's provided by the cable TV company, then they're going to spend some effort making sure we've got quality of service in between the hobbyist and the gateway. Here we're just using a regular internet connection, so nobody's really taking any close looks at quality of service to get to the gateway. So the end-to-end quality is not going to be the same as having long-distance service from your cable company over your cable modem. Now we turn to look at what one might be tempted to call real voice over IP, doing voice over IP inside a building on a LAN. And if we take a look at this diagram, we see that there are a number of components that are introduced into the discussion. One is an IP telephone, another one is the LAN, and then we've got the gatekeeper function and the gateway function. And what we're illustrating here is starting off by deploying IP telephony inside the building as a standalone that's plugged onto the existing telephone system. And the existing telephone system inside the building could be a PBX, a private branch exchange, or it could be Centrex service from the telephone company. Same idea. The IP phones are terminals, and they provide a number of functions. One of them is the human-machine interface. So they allow you and I to get access to voice over IP communications. And it would have a microphone and speaker for doing the conversions between sound pressure waves and analog electricity. It would have a codec for doing the analog digital conversion and then coding that into whatever standard we happen to be using to represent the digitized speech. And it would have to perform functions like getting an IP address. The gatekeeper is a set of functions that are responsible for controlling a group of terminals. And a group of terminals, these are the IP phones in this picture, is called a zone. And the gatekeeper performs a number of functions, the most important of which are registration, admission, and status. Registration would be taking care of giving each of the IP phones an IP address and knowing what it was and possibly doing address translations. Admission is whether somebody's allowed to make a phone call or not, and there would be a couple of reasons why somebody would be allowed to make a phone call or not. The obvious ones is, can you get there from here by doing voice over IP? Another one would be, do we have any capacity left on our communication system to add just one more voice over IP phone call? Or are we used up all of our capacity, and if we let somebody initiate a new phone call, the quality of voice is going to go down? And so what we would do is prevent anybody from making any more phone calls over the system in order to keep a good voice quality for all the people who are already using it. So this would be part of the admission function. And then status, of course, are you busy? Do you have voicemail waiting? Things like that. The LAN is essentially made up with twisted pair cables connecting the terminals to switches. And we're certainly going to go over this in the course. This is just the introduction here. But the idea is that we're using category 5 or 5E or 6 cables that go from wall jacks in the cubicle back to a switch in a wiring closet. And what an Ethernet switch does is it moves frames back and forth between the terminals over the physical wires. This implements the basic underlying communications at 100 million bits per second, or possibly 1,000 million bits per second gigabit Ethernet. Now with this setup, all of the terminals connected to an Ethernet switch and having the gatekeeper, which could be running on a box called a gatekeeper or on a box called a call manager, then people can make phone calls from one cubicle to another over this voice over IP system. If they want to make a phone call from the voice over IP system to somebody inside the building that has a regular telephone connected onto the traditional telephone system, then we have to connect this little island of voice over IP to the rest of the phone system via a gateway. And the gateway does two functions. It converts the format of the voice from the voice over IP world to traditional telephony, and it converts the signaling, the call setup part of the story, from the voice over IP world to traditional telephony. And then in this diagram we've got the regular PBX, private branch exchange, and this switches phone calls between all of the stuff that's connected to it. And so that would be regular PBX phones to regular PBX phones, or regular PBX phone onto the voice over IP gateway, which then would take care of sending them the rest of the way over the LAN to the far end phone. And then this whole story is connected onto the telephone company using traditional telephony. We could also start providing value-added functions running on computers connected onto the LAN as well. And some easy examples of value-added functions would be voicemail, call detail accounting, interface to billing systems, and things like that. This is not necessary, but of course is going to be what you end up spending most of your money on, is buying all of these value-added functions. To implement what we had in the previous scenario, there would be a couple of basic choices. Companies that make PBXs, well, this would be their approach. They would say, well, you don't want to go off and buy a separate gateway and gatekeeper. What you want to do is get the hardware and software upgrade for your existing PBX, and then you plug a card into the PBX. It's a LAN card, and then you just plug the switch into that, and then all of the voice over IP phones go into the PBX, and the PBX performs the function of the gatekeeper to control the phones and do the network address translation. And it also provides the gateway function to convert from voice over IP telephony to regular telephony inside the PBX. So this would be the approach from the companies that make PBXs. They would say, just buy the upgrade to our PBX and plug a LAN card on there, and then you can plug all your IP phones and buy the software upgrade to do the gateway and gatekeeper functions. And basically what you're doing is leveraging your existing investment, and it allows you to deploy voice over IP. And there are some attractive ideas here, because what it lets us do is to keep all of the existing stuff running while trying out voice over IP with a few unlucky guinea pigs in our organization. And we don't have to go out and buy separate stuff from people that we don't know. It's an upgrade from people we already deal with, the PBX manufacturer. And in theory, they need to have one point of contact for trouble and